For our project, we'll be presenting the conveyor bottle sorter. Listed here are the contents of our project, the objective, design, circuit analysis, and code. Also conclusions and the sources we used. The four main objectives of our project are to create a self-sufficient system to sort bottle and can recyclables, use computer vision to separate the items along the conveyor belt, to improve the nature of recyclable sorting by reducing sorting time and human labor, and implementing machine learning used for object detection for each recyclable. Shown here is a complete CAD design for our bottle sorting system. It includes the gearbox, the pie camera, and the lever. The conveyor is made of a PVC polyamide and is driven by a 300 RPM NEMA 17 motor. The conveyor speed is calculated and reduced by the gearbox to 40 feet per minute. On the right is the lever that rotates 45-degree angles for the bottle. Here shows the table for the gearbox. These values include the tooth number, diametral pitch, gear ratio, RPM, and pitch diameter for each stage of the pinion and gear. These values are important for the bending and contact factor of safety to reduce failure. For our gearbox, list three areas of the shaft: the input, intermediary, and output shaft. Each shaft is important in calculating the stress analysis and diameters throughout all three shafts. Here shows our calculations for our bearing. We use the deep ball groove bearing to analyze each bearing of our gearbox. On the table analyzes the rating life and C10 value.
The hardware chosen for this project was a Raspberry Pi with an accompanying camera along with two NEMA 17 stepper motors and the two stepper motor drivers required to run them. The hardware is set up as shown in the diagram, with the Raspberry Pi being the main component, having the camera and the two drivers linked to it, with the motors being attached to the driver. As can be seen in the picture, the circuit itself is fairly simple, having only a few components. For the circuit to work, two power sources are required, one which powers the Raspberry Pi and the other a 12-volt source, the drivers and motors. In order to prevent any voltage spikes from the 12-volt power source from damaging the drivers, two capacitors are placed strictly in between the driver and the power source. The software flows as shown in this diagram, first initializing the speed or step size of the two stepper motors and then their direction. Only the stepper motor for the conveyor remains at a constant speed and direction. The position and direction for the actuator, on the other hand, does change in regard to whether or not the image is a bottle or can.
To implement computer vision, we're using open source software libraries, including TensorFlow and OpenCV. TensorFlow is made specifically for developers to work on deep learning and implementing neural networks. OpenCV is made to focus on real-time object detection, which is what we need for this project. For the model, we're using the quantized TensorFlow Lite model provided as an open source on TensorFlow website. It is designed for developers to implement computer vision on devices like Raspberry Pi. Some benefits of it include low latency and small binary size, which means it is faster and less power consuming. The only downside is that it will have a minimal drop in accuracy. The model we're using is trained by a machine learning algorithm called CNN, convolutional neural networks. It has filters in between layers that detect patterns in the images. From the beginning, it detects edges or lines, and as it goes to the deeper layers, it will be able to detect more sophisticated objects, such as mouth or eyes. To test our computer vision system and circuit, we're using LED light bulb representing lever. You can see whenever the camera sees the bottle, the LED lights up, and when it's a can, nothing happens. For our budget, the total will be around $216, which is about $70 per person.
In conclusion, this project tested our knowledge in both electronics and mechanical skills. We made a small mechanical structure of a conveyor belt and required diligent calculations. The mechanical calculation for the gearbox and shaft was trial and error in order to get valid factors of safety. We were able to effectively detect the bottle instead of the can, therefore the Pi camera input sent a command to the lever to close in once the bottle was detected. And our sources are as follows.